And we have log base 2 of x minus log base 2 of 3x minus 1 equals 4. Okay. Again, this is asking us to solve, so we expect to end up with x equals some number. We want to work the equation down to the point where we have log base 2 of something equals log base 2 of something. If we have that, the one-to-one property says if you have log of something equals log of something, then the somethings have to be equal to one another. So that is how we're going to get rid of the log notation or the log operation, is simplify the equation down. So we have log of something equals log of something, and then we can then assume that the somethings are equal. We don't divide by log at that point, right? Right. So how can we do that? Volunteer, raise your hand. This is in parentheses. How do we combine the two logs on the left, Jonathan?
So it would be log base 2 x divided by 3x minus 1.
All right, wonderful. We're subtracting the logs. We're going to combine them by dividing what we are taking the log of. And it's not very intuitive, but that's the way it works. Okay. What about on the right-hand side? Can we convert 4? Can we describe it as log base 2 of something?
Yes.
Yes, ma'am.
Log base 2 of 2?
Log base 2 of 2, let's see. Log base 2 of 2. So log to the base of answer equals exponent. If we had, that's going to be off the screen. If we had this thing here is equal to 1. You're on the right track, but you're not right. And we'll talk about the mantra. Log to the base of answer equals exponent. Tyler.
Log base 2 of 16.
Log base 2 of 16. Great, so let's see. This is equivalent to 4. Log to the base of answer equals exponent. Okay, so this is the exponent above 2 that gives 16. 2 to the 4th power, 2, 4, 8, 16. Great. At this point now, we have log base 2 of this equals log base 2 of that. We can assume that x over 3x minus 1 equals 16. And from there, it's looking like an equation that's a lot easier to solve. No logs involved, etc. So we will solve that, but let me show you what the real common mistake is. The real common mistake is at this point, people just say x minus 3x minus 1 equals 4, and just sort of ignore the logs, pretend they're not there. Totally wrong. Okay, so don't do that. The other common mistake is people combine these, and so they say x over 3x minus 1, but then they forget to convert the 4, and they just say that that's equal to 4. Real common mistake. Don't do it. I see you laughing back there because you made that mistake. All right. How can we solve? They're not the only ones. How can we solve?
Times by 3x minus 1.
Good. Multiply both sides of the equation by 3x minus 1. And cancel, cancel. X equals, what's that, 48? X minus 16. Add 16, subtract x. 16 equals 47x, and I don't know if this is still on screen. And we would end up with x is 16 over 47. Okay. So we get an answer. In this case, we got one value for x because the equation we ended up with was not a quadratic. We get one value for x. Is that an appropriate value? Is it an allowed value? sure? You mean, yes, it is, because we would not be taking the log of a negative number, okay? So just like in the rationals, you're not allowed to divide by 0. In the logs, not allowed to take the log of a negative number. Okay, so if you get some answer, for example, if we ended up with x equals negative 10, you say, you know what, that's not going to work. Because we put it in here, we're taking the log of a negative number, it's undefined. We put it in here, we're taking the log of a negative number, it's undefined. You would say, not allowed. But we have a positive value, we put it in here, we're taking the log of a positive number, no problem. Great. Okay, so that's an example of solving a logarithmic equation. Question?